very much to Jasper and Alejandra to organize this workshop and for inviting me. So today I'm going to present some research on the Facebook data that we have already seen and that Umberto has already presented. I will showcase some different projects that we have done with this data. I'm not able to move. Okay. So basically, what I was saying is that we're going to leverage this Facebook advertising data to study migration. And the research question of all these different projects is what can this digital trace data add to the traditional data sources? And I mean, we are in this room, so we already know a little bit the answer to this, but this was like the base of also my PhD project. And I'm going to use this data from a Facebook advertising platform that Umberto has already introduced, so I will not spend much time explaining them, but the variable that we use mostly in this in the project that I'm presenting is the expat variable. So this migrant variable that is telling us how many Polish migrants there are in the UK. And we don't have a definition on how Facebook is providing this, this estimate. We know that there are multiple information that are used to infer this characteristic. So this could be like the social network of the users, the language that they speak, and information that also they provide on their social media. To show you that actually this seems to work, these are like some ads that appear on my Facebook and the Instagram account. So the first one is playing on the mama boy cliche of Italians, suggesting that I should buy this mug for my mom. And it says like the love between mother and son doesn't know any distance. And on the right, on the left, there is another one with for the Euro Cup some years ago, suggesting that I should buy these socks. But to show that actually we don't, this variable is good, but there are some limitations. When I was back in Italy during COVID, after around 6 weeks, I started to receive ads that on Facebook, they were showing me that since they were considering me as a British expat in Italy, they were showing me that I could buy this VPN to watch British television. And on Twitter, so another data source, but they were giving me information about Brexit and how to register to become like a resident in Italy. So we know that the time span in these data sources is much different than the traditional estimates of migrants. So the idea of all this research is that we should not substitute the data, the traditional data sources that estimate migration, but we should combine them, and especially we should focus on doing a data assessment of these different data sources, because no data is perfect about migrants. I think we can all agree on this, but we know that there are pros and cons of each data source. And the idea of this is like to combine them, to try to understand what are the biases and try to have a better estimate. The focus on this, on my research was mostly on the UK. And the UK is a very interesting case because they don't really know how many migrants, and especially European migrants, there are in the country. Brexit has happened, so this has also complicated things, but they are not using registered data or admin data as the other European countries to estimate migration. They are using especially survey data, so the International Passenger Survey. And for stock, they are using the labor force survey. At the moment, they are planning to use multiple data sources. It's called RAPID. It's still an ongoing process. But we also saw that RAPID has a lot of mismatches with the census data. The census in the UK was run in April 2021. It was during a lockdown, so also we cannot really trust this this data source. But this is just to say that the UK is interesting, and we don't have a ground truth to estimate migrants. What we did was using the integrated model of European migration theorized at the Center for Population Change in Southampton. And we started to use this framework to applying it to the digital trace data. So we started like looking at what are the data that are going into this model. We use the survey data from the Labor Force survey. So this could be expand also to all European countries because the LFS is like a European-wise survey. We use the Facebook data, and then we include also in red other migration covariates for like explaining the reasons for migration. So population characteristics, migration flows, and economic variables such as GDP and unemployment rates. We did this data assessment in terms of definition, biases, and coverage. So in terms of definition, we know that the LFS is following the 12-month definition of an international migrant, but Facebook is not. We think that is like a much shorter period, and we don't really know what this one is. Both the data from the LFS and Facebook have biases. So from the LFS, we know that there are underreports, and we know this from the literature. So LFS has been compared with the census data in 2001 and 2011 in the UK, and we know that there is around a 30% undercount of European migrants in the UK. But we know that also Facebook has fake and duplicate accounts that might bias what these estimates are providing us. And the coverage is different. So from the LFS, we have a sampling framework. I mean, we have a sampling problem that hard to reach population, and especially young migrants in the UK are not surveyed from the structure of the framework that they use. But also we know that Facebook activity depends on the country, on the age, and the gender. So this has effects on who is actually using this platform. But basically, we use all this information. We try to estimate what are like the problems of both data sources, and we combine this in this hierarchical Bayesian model to try to get an estimate of the true stock. And we did this with Bayesian models, so we did simulations. And what is nice also about Bayesian model is that we can try to repredict the data. So if the model is good, we should be able to get back the data that we fitted into the model. So basically the explanation again for why using this approach is that we can provide a coherent description of the uncertainty of the estimates. So I can also say that Facebook has a 10% bias or a 4% bias and try to fit into this model. We can include the expert judgment, in the sense I could ask all of you to tell me what is the mismatch in the European estimates in the UK, and you will provide me with a number, and then we can fit this into the model. And another good thing about this model is that it's a natural way to treat these highly structural models, so multi-level models, into this framework. And this is like the model, so that is like the structure of the hierarchical model, and is this Bayesian hierarchical model, and we use this for estimating the true estimate. But this with the QR code, you can find the data, you can find the code, so everything is available online and it's reproducible. But these are like the estimates that we got from it. So maybe they're a little bit small, but I have 3 countries, Poland, Ireland, and Italy. The green one are our estimates. You see that there is a large uncertainty. In yellow, the LFS. In red, the EU settlement applications, and in blue, the Facebook data. So you see that also the Facebook data have a mismatch. We see that there is a lot of uncertainty around the green, so the model estimates, but we see that overall we are estimating more migrants than the LFS is suggesting. And I think there are some interesting things. So like with Ireland, the Irish, they don't need to register for pre-settlement or settlement status. So we see that the red one is almost 0, but the Italians, they do need to register. And we see that the red estimate is higher than the LFS estimate, and it's closer to what we estimated through the model. So we see that there are some of these mismatches that might tell us that in which direction the LFS might be biased. We can do this for all the European countries in the UK, so all the European nationalities. We can disaggregate by gender, by sex. This is also important to try to find the differences across populations. And we were able to provide this estimate for 2018 and 19 of the mismatch. So overall, it was a 25-20% undercount from the LFS in reporting the European migrants. But we could continue to do this and check how this is ongoing. We try to extend also the model. So this is unpublished work still, but we wanted to, in migration is really important also to have these estimates disaggregated by age and gender. So we went back to formal demography models and what we know from the past. And we know that there are some similarities in the age for which migrants are leaving a country. So we used the Roger Castro model published in 1981, 83. But with the Facebook data, as we were hearing before, we need to be more careful because we don't really have anything under 15. And the last age group is 65 plus. So we cannot really see migrants that are older than 65 plus. But we can really see the age between 15 and 65. And we did this by categorizing also the countries into 3 different groups, Western European countries, and Italy is shown on the top. The Republic of Ireland by itself, because it has a very weird pattern, but this is historical movements between the 2 countries, so it's very different from all the rest. And the Central and Eastern European countries on the bottom. This model, there is a lot of harmony in the age structure between the LFS and the Facebook data, especially for Central and Eastern European countries. And my explanation, our explanation for this is also because the migration is much more recent. So after 2013, and we can really see that this is a young migration and the 2 data sources are very similar into this. And for extending the model that I showed you before, the Bayesian hierarchical model, we added another component that is this multinomial Dirichlet for disaggregating the estimates by the age structure. As we heard, one of the very good thing about this data is that they are timeliness. So we downloaded from 2017 data every week. And here we have 9 European countries, again in the UK. And you can see though that there are some differences. So we don't have control on these estimates, and the companies, they don't really tell us everything about what they're doing. So we saw that in March 2019, there were a first algorithm change that affected the estimates. So we noticed a drop. And then in March 2020, again, there were another jump. This time it was upwards that affected the estimates. So here it's a log scale, but you could see it also in absolute numbers. There are these jumps. For this other paper, what we did was then deciding to analyze only the period in white and not analyze the 2 other points. But what we were able to see by doing this is that there is this decline in the Facebook activity of European migrants in the UK, and we wanted to understand how this relates to Brexit. Now in this dashed line, I plotted also the labor force survey data. So you see that there is a tiny little bit of decline, but it's not as pronounced as with the Facebook data. But and also we really see that the LFS data are just yearly. I mean, we could get some quarterly estimates, but the Facebook data have a disadvantage of being weekly or even daily. So by doing this, again, we were downloading the data by age. So we created like a different age groups. And we can see like in absolute numbers, which are the groups that have the majority of active users. So we can see also their education, and also for studying like a policy effect and how if Brexit is working or not. It will be interesting also to understand if they are still able to attract highly skilled migrants, or if the highly skilled migrants are staying into the country. I mean, I need to go back just 1 second. The education variable is tricky though, because it's based on the US system of education. So it considers like colleges and so on. And so we did have to do some grouping of these variables, and at the end it was secondary, tertiary, and unspecified. There are a lot of people that don't specify their education level, and this is probably one of the variables in which Facebook is not doing any estimating or inferring, so they don't infer our education. So we see that there is a lot of unspecified people that they're not falling in any category. Here we use like a log linear model with an intercept and the slope, and the indicators variables are age, education, and country. But we always have like a reference category, but it's interesting to see which is like the age group that is decreasing faster than others. So we see that it's basically 20-29 years old. So from the slope, we can see that in comparison to like the reference category here for education is a secondary education, and actually tertiary education is decreasing faster than secondary education. We can see differences across countries. So Romanian and Polish are decreasing faster than Italians, and other European are not as decreasing as fast as the Italians. But the meaning of all of this is not really to create like an estimate, a weekly estimate of the migrants, but it was more to check how we can use this data to infer like declining trends or changes in trends. In the case of the UK, we were interested to see what were the effects of Brexit and the uncertainty surrounding Brexit, and how this might affect like migration choices. And this stock data might be really good to infer like this change over time in a country. I think there is the need of a lot of work, and the people in this room are doing a lot of work on like this topic, and using like different novel data sources. And also because as we've seen, like different data sources have their own challenges. But what we were trying to do also with the Bayesian model, the hierarchical model, was when Facebook also will not be anymore the social media, we will be able to have like a model that could combine these data sources, so that a model that can be used also in the future to estimate the migration when Facebook will not be anymore the social media that the majority is using. I wanted also to address like some of the limitation of Facebook and also some of the advantages. So we work also with surveys, and during COVID we interviewed a lot of people, and this research was basically about changes in the behavior related to COVID and to the pandemic. But since we did quota sampling on Facebook, and we targeted by age and gender the Facebook users, we were able also to compare the targeting features with the reported features from the survey. And what we were able to see is that Facebook is actually providing demographic estimates quite correctly. So it was a 90% were identified correctly by age, sex, and place of residence. The thing that was like tricky was especially for actually Brussels and London to identify location, but this is so the location was like the weakest variable to infer. But this was also because of people that are commuting in very large areas might be considered at home in two different places, or they have very large range when we are targeting them. But for age and gender and sex, the Facebook data were correct at like 96%. Another thing that I want to mention is also that we just published this paper with the colleagues in Oxford. This was a paper led by Doug Leisure. And as the people in the GRC, we use the data from Facebook to estimate the displacement in Ukraine from the 24th of March. So Doug was very smart, and on the 24th of March started collecting data daily for all the different countries in Ukraine. And we started collaborating with IOM and to provide these estimates in for inferring the displacement of Ukrainians. And we really saw that one of the advantages of this data is when the traditional surveys are very difficult to be implemented, the Facebook were providing these estimates. And there were maybe a question before about if we are also able to see like a return migration from this data. And actually for the Ukrainian case, we noticed that. I'm not showing here the time series, but with the Orthodox Easter last year, we saw migration back to Ukraine. So we saw a jump back of activity that probably was led by the Easter Orthodox Easter in Ukraine that was celebrated, and people were moving back to the country. So there are some limitations about all of this data, and I was trying to summarize it as a transparency. We don't really have like a good definition from this data on who they are targeting. There are these algorithm difficulties also when there are these algorithm changes and ethics, but surveys, and then there will be Stefan speaking, might help us really addressing this challenge of understanding who is captured by this data. And what we are also doing in Oxford is trying to create a collaboration, not really with Meta because it's very difficult, but also with other companies that are that might have data to estimate migration features. And that is all. Thank you.
Yeah, thank you for the invitation to this great workshop. Before I start, I want to point out three things. Some of them are obvious, some are not that obvious. So the first thing is, I think I'm kind of the outlier, at least so far, because now we are going into surveys. So I'm in my research, in the research I'm presenting, our research with other people, we are not using new data as such and analyze it, but we're using social networking sites as a tool to help us to collect traditional data. That's the first thing. The second thing I realized after listening to all this brilliant presentation you already heard, that I, again, might be kind of an outlier here. So I designed that more as a discussion input. I hence apologize in advance if you find it too obvious. There are not any results or anything here, so apologies. Third thing, I changed the title because first of all, it's about Facebook and Instagram, or Meta, however you want to put it. But also, I decided to go a bit beyond the migrants, and I will come to other hard-to-reach populations, at least in a footnote. This is all based on a lot of projects, which obviously I didn't do myself alone. I was obviously involved in them. So those are people who collaborated. Some of them are in the room, and then that's a lot enough of introduction. So I'm gonna try to be brief. First of all, why are we doing what we are doing? So why would we think that using Facebook and Instagram Meta products would be interesting for sampling? again, I think it's very obvious, the first point, and you have heard that a couple of times today already. It's the huge user base that allows us to get in touch with a lot of people really easily. It's open for scholars to use. You don't need to cooperate with Meta in any way. And what you do, in our case, is covered by their terms of service. And there are specific advantages, which I'm not going to read out. So those are more from a survey research perspective, thought from a survey research perspective. So it's fast and easy to realize. It's available nearly globally, this type of sampling. At the same time, you can really become very specific. And also for, if you think about migrant surveys and forced migrant surveys, which we have done as well, you don't have to bother about gatekeepers. Obvious limitations. Of course, coverage is the most important one. We can only reach directly people using this method who actually use Meta. I think that's kind of obvious. Everyone else, we can at least not reach directly. We have several digital divides, which we might have to take into consideration and so on. And we have a self-selection of participants. Then now moving on more to the, what do we actually do? Again, I try to be very brief here. You see one of the advertisements we use. So this is what we do. We use Meta social networking sites to actually buy advertisements, which then include, contain and link to an external survey. And as I said, external means that all the data we actually collect is beyond the Meta environment. And just as a footnote for discussion, we do actually not use Metapixel. So people who know what Metapixel is might want to tell me or ask me why not. And I can explain it on. Now, a short advertisement. If you're interested more in detail how to do this, there's an open access guideline coming up next month. So that's now an overview of the projects which we have done. Just to give you an idea, again, obviously, I'm not going to go into details here, but you can see we use that for regular migrants, for forced migrants, residents in different countries. And I actually realized I forgot a rather huge cross-country study we just did in Sub-Saharan Africa to include here. But we also use that for health sector workers, and that's the beyond migrants thing I want to talk about as well. And you can also see here that the costs differ quite a bit. So it is in most cases really cost efficient. But if you do some quick math, even though this project is still going on, you see a slight difference there. And if I would go into the nationalities, this difference would even be bigger. But also, this is skewed because here in this project, we look at a very specific population. So we have an age range, and actually it's a project in Canada where we look at refugees from those countries in a specific age range, and actually also beyond the metropolis. So beyond Toronto, Quebec, and Montreal. So that much to that. Then why, again, a bit, what do we gain from this? So this is an example of a study of German immigrants, which we did globally. And I just want to use that to show you in a minute what the benefit of this can be. So there are not many studies on immigrants so far, but there is a very brilliant study that has been conducted 4 years ago, I think, by colleagues in Germany. And they actually use the population register to contact immigrants, because Germans have not only to register their new, their moving within the country, but also when they leave the country, and they can supply an address when they do so. So for this reason, in our study, we asked people whether they actually did this. And you can see here that 15% of the people in our sample provided an address and could still be reached there. However, you see also here that 20% did not deregister. Then for another 17%, they didn't provide an address. And for 8%, the address was not valid anymore. So these people definitely could not have been reached with the approach our colleagues used. And there are a bunch of other people for whom it is highly in doubt. So moving on to specific challenges. And again, I'm gonna focus here only on a few. So the first one is targeting. You have heard about this already, that Facebook Meta, the Facebook Advertisement Manager, offers us a lot of possibilities actually to target people. So the main indicators that are used in research, especially in migration research, are location. So that is actually something you have always to do. You have to define a location where you want to sample people. That can be a country, a city, a radius around a building or whatever. And you have to say how people should relate to that location, gender, age ranges, languages. Then you have, and this is of course, you have a lot more. Those are just examples. Bunch of demographics, interests, and two behaviors, and this is meta lingo, so I didn't come up with this. Two behaviors that are relevant for migration researchers. You have a lived in country X indicator, to which I come in a minute, and a generic lives abroad indicator. But now the problem, you only have a limited number of indicators that you can use. And especially the country and cultural related indicators are not universally available. And that has Francesco already pointed that out, for example, and others this morning. The lived-in country X indicator, for example, does not exist for Afghanistan or for Ukraine. And also languages do not exist for all languages we could think of. For example, Quechua, you will not find in the Facebook Advertisement Manager. Some of the variables also depend on self-identification of users. Francesco just mentioned that in terms of education, for example. And also, as Ingmar pointed out, Meta might deactivate actually options that we could previously use for targeting. So, meaning we cannot reach all possible target population through the use of target variables alone. And this is why, if you do this, you should actually think about targeting in a larger term. So targeting is more than targeting variables. We differentiate between primary and secondary targeting elements. I'm not gonna talk too much about that, but the general idea is talking about primary targeting elements, that besides targeting variables, you have, I mean, you do advertisement in an audio-visual media, so you obviously have other things. You have the media elements, you have wording, and you have language, which you should carefully consider. And there are now two, hopefully quick examples, starting with the health sector workers. So how can we use seemingly unspecific targeting and still get good results in terms of N? So when we targeted health professionals during COVID, we actually used three targeting strategies. We targeted the general population of Germany in Facebook, general population of Facebook users in and Instagram users in Germany. That's to put it correct. Then we combined this, or we limited in strategy 2 this by focusing only amongst them on people who actually say they work in healthcare. And in strategy 3, we focused on people who are interested in healthcare and nursing. So, and then if you do this, you get estimated reach. And here you see already the huge differences. General user population, people who work in the industry, people who are interested in this. And Of course, if I tell you we targeted all users, then comes in what I just mentioned before. It's not just about the variables, it's also about the content. So while we targeted all users, we used very specific pictures. Our survey had a very specific title. The text was very specific. And this is what we got out of it. So most people actually, we got from our very general targeting. This translates to 150 roughly out of the 64,000 we saw before. And those are interests. So the very general targeting even works slightly better than the interest-based one. And if we think about refugees, Syrian or Ukrainian ones, it works similar. So we have also here a problem with the language. If we talk about Syrian refugees, Ukrainian refugees, if we target them using Ukrainian, yeah, Ukrainian is not widely spoken by other people. Arabic is. So again, we combined it with specific pictures and specific text, and it works quite well. Biases, very quickly. The general things, I already pointed that out. One is coverage. So what you could do here, think about in terms of strategies, you can combine, and we did this in the discussion. I could tell you a bit about that. We did it in a rather unsystematic way so far, but you can think about snowball sampling and respondent-driven sampling. And then in terms of selection bias, so selection even amongst the Facebook users, you actually should think about stratification, and there's a way to do this. So you can target specific age ranges or along other categories which you deem important separately. And with this, I now come to my discussion slide, where I try to think a bit in terms of, okay, what would this now mean for sampling and surveying irregular migrants? So obvious thing first, there is, for a very good reason, no specific targeting variables for them. So the approach I could only think of, as we cannot exclude people actually. So based on the countries they lived in, because that was my first idea, target all migrants, exclude EU migrants. Boom. No, doesn't work. And also for good reason. So I would recommend actually to target still the total migrant population. Also, I would use different campaigns and try out what works, what doesn't. So that's another point with this strategy. You have to be a bit flexible, but you also get constant information when your campaign is running. So, as I said, target all migrants, irrespective of legal status or origin, and then use rather routing or filters to bring them in different parts of the questionnaire. So I would not actually use screening per se, because you have to keep in mind that people can post comments beyond your advertisements, which you can hide, but you will not do this in real time. So what you don't want is people posting, yeah, I found out this survey is to identify irregular migrants, so please do not participate, it might be dangerous. So you don't want to do this. Another possibility would be to actually frame, and with this, again, I mean pictures and text, frame a survey as something on a specific topic, with which you might also find irregular migrants. So the only thing I could come up with, and obviously this doesn't apply only to irregular migrants, but I would think among migrants in precarious employment, or the other way around, working irregular migrants will probably in many cases be in precarious employment. So if you try to frame the survey this way, you might have a chance to have a decent number of them in your survey. And in general, one could think about a two-stage survey process. So having first a kind of recruitment survey and then a follow-up, which also would you allow to have actually different framing for the first survey. You could then only target irregular migrants in the follow-up survey and even incentivize them, but still, main problem will be attrition. So you will lose people which you would otherwise have in your sample if you go with one survey only. And then again, snowball and respondent-driven sampling. Thank you.
Thank you very much. So this is about ethical and legal concerns on data science for large-scale human mobility. This was a book chapter that find itself in the Data Science for Migration and Mobility book that we have recently published with Tuba and MIrreM and Korkmaz in Oxford. And the main question is, what are the key ethical and legal issues when we try to use the new technologies, new data sources? And this is part of the Hummingbird research project, but my own part in Hummingbird focuses mostly on mobile phone data. And before the Hummingbird, also coordinated the Data for Refugees project in Turkey, which was built on mobile phone data. So I will mostly give you examples from that domain. The first question that needs to be answered, and that's especially in my own field, I'm a computer scientist, where our students are not very familiar with this part of the question, is why do we need ethics and what it means to have a look from this perspective. And applied ethics at its core is supposed to guide actions. And the core question here is, what should one do in a given situation? So this has an implication for data scientists. It tells us that not taking an action is also an action, right? So if you have the capability, for example, to create a system that looks at multiple data sources and helps in a humanitarian crisis, that's an action, that's a positive action you can take. And not doing that has also implications. So one thing that I see in my students when I give the social computing, computational social science class is, as soon as we discuss the ethical aspects and then propose to convert a social scientific question into a data scientific question, they will immediately say, let's not do this. You know, it's not ethical. We're going to be looking into a lot of data. But that's not a very good perspective, because there is a positive impact that we can make, and that impact is gone if you choose that aspect. But you have to really look at the different ethical aspects in order to not to cause any harm. And in data science, we have the ethical aspects that we need to review in three different areas of any project. We have to look at the ethics of data, in terms of collecting data, storing data, using dataset biases, getting consent from the owners of the data, the risk and benefits of the analysis, and transparency. We have to look at the ethics of algorithms, whether the algorithm actually works the same way in different types of populations and different subgroups of population, whether it's fair or not. Who is responsible from auditing the algorithms? Are they transparent enough? Do they generate trust? And these kind of questions. And then we have the actual deployment of algorithms, which is something that as researchers in a university, we're not too much concerned with, because deployment is now something out there in the field. Then you need to think about power and authority and user rights. And also function creep. So you deploy an algorithm for one purpose, can somebody else appropriate it for a different purpose? Like the classical example is the pushbacks from algorithms that detect boats on the Mediterranean that can be used to help the refugees on the boats, but also can be used for the pushbacks. Imagine the following application. So this is a pilot study that we are conducting now. You have the asylum seekers, and the border police ask for their phone. They take the phone away, and they do some content analysis on the phone. They look at the images on the phone. They look at the locations, the GPS traces, the applications, the language settings. And this is done, let's say, with an AI-guided algorithm or a set of algorithms. And based on the information that they get from the phone, their decision of granting asylum or not is affected. We work with the authorities to understand whether this pilot is called, it's called an Athena project, whether this is actually doable or not, and what are the perceptions of the asylum seekers, what are the perceptions of the different institutions that are involved in this pilot. And it's a landmine, like a field of landmines, right? There are a lot of risks. The analysis algorithms may be trained with biased data, so they may give you incorrect results. The asylum seekers, they're not in a position to withhold consent, so they cannot say, I'm not going to give you my phone, I will retain it, you know, just do your decision without that. There's a power relation at work. The application will work as a black box, so the asylum seeker will not know what's going on behind the scenes. The data collected can be compromised or leaked, because one of the biggest concerns is, let's say you're a political asylum seeker and your data that you give the phone away, but that data somehow reaches your original government, and that will, you know, compromise you. Multiple agencies are involved with unclear responsibilities, and the data can be stored for much longer duration than it's necessary. So then the question is, can a proper ethical screening process address all these issues? And are we capturing all the issues really? Maybe there are others that we don't know about. So what people usually do is they get a bunch of ethics principles and they try to stick to them. But since 2015, over 100 sets of AI ethics principles are published. Now, there are some threads running around, you know, you can see that this all goes back to principlism. So you try to respect the people, you know, you go for beneficence and justice. And there are some intrinsic values, like you want to promote autonomy, minimization of harm, and justice. These are values that we try to promote as in themselves, like they're not connected to anything, but we want to promote them. But then we also have a bunch of external values like privacy or transparency that relate to these. And we want to promote them not because they're important per se, but because they are actually helping autonomy and justice. So privacy in itself is actually not the value that we are pushing for. It's the autonomy and minimization of harm and justice that we try to ensure. Now, AI for social good is an important concept, but there are framing issues here. AI, especially in migration, whose good are we talking about? Is it the good of the government, or is it the good of the migrant or the refugee that we're talking about? Sometimes these actually clash. So depending on the application setting, you need to position yourself carefully. Another problem is that technology has far-reaching consequences that are very difficult to guess. Now imagine an application developer working in Twitter. They are coming up with an algorithm that will show you, for example, tweets that you will like, right? So that's their cost function. And they do a good job, all right? So you see tweets that are interesting to you and you click on them and everybody's happy. 5 years later, there are huge gaps in the society because Twitter has created echo chambers, and radical people are more radicalized because they don't hear the other anymore. Okay, so could you have anticipated this as a simple recommender system programmer? Are you equipped to ask these questions even as a computer scientist? So another issue is the proper level of consent. For example, we work with mobile phone data, and the agreement that you sign with your mobile phone company says this data can be used in an anonymous way for research purposes. Now, if I do this, did you already give consent to me? Did you actually read that line even? So there are issues of conceptual clarity, especially for the migration domain. Of course, de-identification, anonymization, and re-identification of data becomes important. And GDPR is trying to basically keep seek to like draw a framework of data protection, keeping the data safe from unauthorized access, and also data privacy, right? Empowering the users themselves to grant access to people and applications and systems and institutions about their data. However, there are simply too many stakeholders. For example, you're all using browsers. You're using Google Chrome maybe, or Bing. More than 400 companies are using your data at this moment because this data is shared and shared and reshared and resold and distributed all over the internet. So it's very difficult to keep track of this. I'll give a bit of an example from the Data for Refugees Challenge, where we collected data from 1 million customers of Türk Telekom, and we opened it as a data challenge. The data challenge is important because one of the main ideas in ethics is that there are so many risks, and it's important that many people look at the data to give you feedback about the potential risks. The data type that we work with is call detail records. If you don't know what this is, it's just a line when every time you make a phone call, your phone company stores a line. What was the outgoing and incoming base stations? How long was the duration of the call? And we have enhanced this with the refugee tag. So whether this call was made by a Syrian refugee or not. It's not exactly a refugee. It's a, they have a different status in Turkey, but we had some indicators like registration with a Syrian passport, or having special IDs given by the government, or subscribing to a refugee tariff were the indicators with which we could tag the mobile phone data. So we collected this from 200,000 refugees and 800,000 non-refugee residents so that comparisons can be done. And we anonymized and aggregated the data. So if you look at the anonymization and aggregation, anonymization is easy. You replace the numbers, the phone numbers, with random numbers. But we also need aggregation, because if I tell you that this person is having these 4 phone calls at given locations, you can probably find who that person is, if you have exact data. But if I tell you that the phone calls are made in a district and within a certain hour, then it becomes much more difficult, because now you're talking about hundreds of people that have phone calls in that area and in that time period. So there are principles established to anonymize and aggregate this kind of data. And the important ethics guidelines were that you have to be able to get the consent. The consent needs to be there to be able to process this data. So you look at the legal agreement for that. You cannot identify individuals. You cannot track individuals. And you also respect the group privacy of people. So if I find, for example, in one area that Syrian refugees are working, okay, and then I do draw some conclusions about that, I can still harm them as a group. And that needs to be checked as well. Okay, so these are about the AI. Let me skip this one. The dual use of technology, let me also skip this one. Okay, so this is, for the mobile CDR project, the main ethics concerns we dealt with were consent, protection, information distribution, access, and responsibility. Now, typically when you do a big data project and you give informed consent, you also give the people whose data you use the right to withdraw from the project and remove their data from the project. But in this case, because we aggregate it to such a level, and we use a principle we call data protection by design and default, where when the data leaves the company, it's already aggregated to such an extent that you cannot find individuals in the data. In that case, people cannot ask you to remove their data from the data set, because you cannot find them anymore. So that's there's a trade-off there that you need to be careful about. The risk assessment needs to cover the entire project, and that includes the application, and that it also includes the publication. So for that project, we had an ethics committee which looked at the publications for identifying potential risks. For example, in Istanbul, during the construction of the third airport, the refugees were working at the airport, and you can see this in the mobile phone data. Or in the tourism season on Antalya, they were not permitted to work there, but you can see the activity. If you publish this result, maybe there will be some political groups that will take on this result, publish it, and actually cause these people to lose their jobs. So you may harm them inadvertently. So the ethics committee's job was to screen all these reports for these kind of instances. Let me not talk about biases, because I think there are a lot of talks that touch upon issues of bias. But one thing I want to stress is that models and systems that rely on big data are also agents of change themselves. So if you create a system that does some prediction, and the government starts to use this system for doing policy decisions, all of a sudden your system is now an agent of change. And you should always think about these complex relations as a nonlinear complex system. So we're not talking about cause and effect relations. We're not talking about lines. We're talking about circles. We're talking about feedback loops. And once you create a system, it becomes a part of that feedback loop, and it starts changing the behavior of people as well. So maybe you have seen this guy walking with 100 cell phones in a hand cart to change Google's behavior, right? So all of a sudden, Google Maps predicts traffic in that area, whereas it's just one guy with 100 cell phones walking through the street. So what happens if these systems become open to manipulation? All of a sudden, we're opening a new can of worms, right? So the ethics panel that was formed by the Data for Development Challenge, which was the first big data challenge on mobile phone data, proposed a bunch of important considerations. They told us that, first of all, you need to form local collaborations, because otherwise it's very difficult to interpret the big data in the context that you're working with, right? So you see certain patterns, but you don't know what is causing those patterns. Statistical biases are very difficult to detect. Having as many eyes on the data as possible is beneficial. So instead of one group looking at the data, make a data challenge if possible, and let 100 groups look at the data, and that's beneficial. More difficult perhaps to realize, but still there is a great value. Taking group privacy into account is important. There is a trade-off between granularity and accuracy, and you have to do this in a risk-based assessment. So how much are we going to intrude into people's life, right? And what are the benefits of increasing the granularity? This we saw also in the satellite data. You can focus quite well, if you use the high resolution data, but then you learn much more about the people. You track them, you are able to track them more. Is it worth the effort? Or can we step back and go to a lower resolution and train models that can do the interpolation, perhaps by protecting the people's privacy? Special precautions need to be taken for low to middle income countries, because there is more data available from those countries occasionally, and there is less protection from the legal frameworks for these people in those countries. For example, I work both in the Netherlands and in Turkey, and we work with patient data. In Turkey, the doctors tell me, where shall we send the patients? In the Netherlands, that doesn't work that way. So if you're studying a risky group, there may not be sufficient protection, but you have to compensate for this with the ethical principles in the project. Yeah, and the rest I have already talked about. So for data ethics literacy, there are two common ways of going about this. One thing is establishing an ethics panel to oversee the project, and then you basically look at every stage in the project. But you need to either budget some cost for the ethics panel, or if this is completely voluntary, you have to make sure that everybody is actually doing their job on the ethics panel and they're not just whitewashing or just carelessly going over the project phases. There are also a number of tools that you can use for the ethics review of your project. The Data Ethics Canvas, or the Box, or Utrecht University's Data Ethics Decision Aid, the DEDA. These are frameworks that are usually composed of a bunch of questions. And it's the research team's duty to go over all these questions, answer them as honestly as possible, and then if some risks are determined, take action to mitigate those risks. For example, the Data Ethics Canvas has 15 headings. One of them is negative effects on people, and it will ask you the following questions. Who could be negatively affected by your project? Could the way the data is collected, used, or shared cause harm or expose individuals to risk? How are these limitations and risks communicated to people? Okay. Maybe only a few minutes about the legal part of this. One thing that our students have difficulty understanding is that the legal aspects and the ethical aspects are quite disjoint from another. Legal aspects, well, the law is built by reaching a consensus in the population, and then in a country, or if it's internationally, an international consensus about the principles, which then are written into laws by considering a lot of different dimensions. As a consequence, it's a very slow process. Whereas in my field now, everything is going so fast that what 5 years ago is no longer applicable. So especially with the deep learning revolution, it's very difficult to keep track of what's going on. We don't know what GPT-5 will look like, for example, right? It's very fast. So law will never be able to catch up with the developments in technology from that respect. But there are a bunch of principles that it will always try to protect. So for the legal aspects in this domain, we'll look at legality, which relies on the concept of consent. We look at data protection, which means about the technologies that you use for encryption of the data storage duration, and the protection of the data in general. And then about identity, and that goes to the Article 5 of GDPR. For AI-related aspects, there are a lot of different risks, and the AI Act is trying to, for example, address some of those risks and to mitigate those risks. Let me skip the interoperability. There is one important issue, important document that you can use for the legal aspects, is the Global Compact for Safe, Orderly, and Regular Migration. And that contains a bunch of commitments and objectives. And that is a good guideline framework for creating systems in this domain. So to sum up, the ethical debate is usually about what is right and fair for AI and big data systems. But there are legal instruments, international and national. That's one layer, but ethics should come on top of that layer. And you have to really combine the knowledge of the computational systems with the potential risks that they're generating. So one potential solution is to educate the developers much more about the ethical aspects. So bring ethics in a much more deeper way into the education of the AI and big data science education programs. Thank you very much. This is my email address. You can always send me comments and questions about this, or if you need to access the text of the chapter, you can also send me an email. And yeah, thank you.